All right, good morning, everybody. Welcome back to, I guess, part 2 of logarithms. In the first chunk of videos, we went over kind of what are logs and how are they kind of inverses to exponential functions. And in this video, I'm hoping to kind of show you how to work with expressions that look mostly like logs. So this one was just about converting, but in this one, I'm going to show you how to simplify expressions involving logs. So it's pretty simple. If you think about what we talked about up here, you really just need to know how to be able to go back and forth between these two versions of saying the same thing. So if you see an exponential and it's to your benefit to turn it into a log, which we'll see a little bit later, then you can do that. Or vice versa, if you have a log and it's to your benefit to turn it into an exponential, to think about it a little bit easier, then you can do that as well. So for example, I see right here, this says log base 8 of 8. And you haven't really learned any of the major log properties yet. We'll start to build that list here. But you do have the intuition to think, well, didn't he, if this was my like answer, let's say, so let's say I just put a random x there, right? Well, we can use our definition of logs and the conversion to figure out what that would be. So I recommend doing it this way. So I think of, so let me make this a little smaller. So I think of this as, okay, I know that's the base of my logarithm, and I tend to use this loop-de-loop trick. So I'll say, okay, this is the base to my exponential. This would be the power of my exponential, and this would be the answer to my exponential. So you can use the little loop-de-loop trick. It'll help you set up an exponential equation that will likely be more straightforward and intuitive for you to solve than just looking at the log. So here, if I asked you, log base 8 of 8, you'd probably stare at me like, I don't know what you're talking about. If I asked you 8 to what power is still 8, many of you would feel comfortable saying, well, 1, because anything to the first power is itself, right? And that is, in fact, the answer to this log, x equals 1. So I'm hoping to show you that if you kind of transform between log land and exponential land, it helps you figure out the answer. But it also shows us our first log property, which is if you have log of any base to that same number, it's 1. And you see why, because of what we just said. Anything to the first power is itself. So that's our first major log property. Okay, if we move on over here, so we see kind of an annoying 5 right there in the front, but if we kind of ignore it for a second, we can always come back. So just remember there's a 5 there. But this says log base 2 of 16. So let me think for a second, and I'm like, okay, if I have log base 2 of 16, and let's just say I give it, I don't know, some number, I can use the conversion trick or the loop-de-loop trick to write this as an exponential. So this is saying, okay, this is my base, so 2 to some power is equal to 16. And that's a little bit easier to wrap your head around and think about. So if you're just like, okay, 2 to the first, 2 to the second, 2 to the third, 2 to the fourth, like you'll eventually fairly quickly realize that this is x equals 4, right? So just keep in mind that this part is equal to 4, but we still have that 5 out front, right? So this is saying like 5 times 4, which is 20. Okay, so I used the exponential conversion between the log and the exponent to get that 4, and then I saw the 5 in the front. So that one's 20. Letter C, again, we're going to first focus on the part that is log, and then we'll come back. So I can figure this out if I have log base 6 of 216 is equal to something. So I can go 6 to this. So this is asking me 6 to what power is 216. And again, I mean, you know, you have the power table in your head. Some of these are pretty intuitive. You know, you can realize what power is being used. So this is going to be 3. So third power. So then only this part, only that red part becomes 3. So this is pretty much now, what is 4 times 3, which is 12. Okay. Then we get a little bit fancy. So right here, if I just call this x, I can use the loop-de-loop trick. So here's my base. 1/2 to some power is 2. 1/2 to some power is 2. So hopefully this is pretty straightforward. You see that 2 doesn't change. The only thing that does change is it kind of rose from the denominator up to the numerator. So when that happens, you should have a big light bulb going off in your head, and it should be like ding, 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 negative number. So if the number didn't change, obviously the power is going to be 1. And if it's moved from the denominator up to the numerator, that's going to be a negative 1. So that's going to be the answer to this one. And I mean, they pretty much keep going. I don't want to do like all of them. I feel like you could probably take on some of these. Let's see, that one's kind of whatever. This one is just double log. So for this one, I would say let's figure out what this is. Then let's figure out what this is. And then, sorry, there was a little multiplication dot in between. Then you can figure out what to multiply. So this one would be 3 to what power is 81. And this one would be 2 to what power is 16. So once, I hope you're seeing that knowing your exponents very well is going to serve you best in this log, you know, thinking, because you need to know your powers decently. I mean, not perfect, but decently. And this one will end up being 4. 3 to the 4th power is 81. This one is also 4. And so this is just another way of saying what is 4 times 4, 16. Yay. Trying to see. Yeah, I mean, for the most part, these are okay. 1, 2, 3, 4, 5. Here, I'll do H, and then I'll call it on this one. So again, let's say we had this answer over here. We would say this is the base of our log. So I have 1/3 to some power is 27, right? And hopefully you're seeing the relationship between 3 and 27. So you could also write this as 1/3 to the x power is equal to 3 to the 3rd power. So you know what the power is already because you've expressed it as a power of 3. But notice that right now the 3 is in the denominator. You want it to come up. So that should be screaming negative power, right? So your x should be -3. Yay. And yeah, I mean, they're pretty much, I don't want to like ruin all of them for you, but, and then these are just, you know, here's 3 of them, do all 3, multiply them together. Here's like, do 2, add them together, and then divide. Like, it's just slightly more complicated versions. I'll do this one. So right here, log base 3 of 27. So I know that's going to be 3 to the x power is 27. And you'll quickly get an answer of 3. So this is just another way of saying 3. Then you go over here. I'm going to ignore that 8 for a second. So this says 16 to what power is 2. And notice that the number got smaller. So this is pretty much screaming to me like, okay, maybe it's a root. And so we could also do it, we could say 16 is 2 to the 4th power, right? And then once those bases are the same, this is just 4x equals 1. So 1/4. So the 4th root. So another way of saying this is just 1/4, and then don't forget the 8 right here. So 1/4 times 8 is just 2. So that's what I have on the top. Over here, we have 8 to some power is 512. So let me think for a second. 8 times 8 is 64. 64 times 8. Yeah, so pretty sure this is going to be third power. So this just becomes number 3. And then 1,000 to some power equals 10. Well, again, you see that the answer is smaller than the base. So that's probably going to be some radical. So let's see, we could write it like this. 10 to the third to the x equals 10 to the first. And you can already kind of see it right here. 3x equals 1 divided by 3. So we get x equals 1/3 power. So this just becomes 1/3. So if I clean it all up, this just becomes 3 plus 2 over 3 times 1/3. 3 plus 2 over 3 times a third, yeah. So then this would become 5 over 3 times 1 over 3, which would simplify to 5 over 9. Okay, so I mean, they get quote-unquote complicated, but you just have to practice them. So I'll leave the rest to you. And in my last video, I'll go over solving some of these simple, notice I said simple, we're going to learn more complicated ways, but simple log equations.